For over 4 billion years, Earth has protected life with an invisible force, a colossal magnetic field acting as a shield against cosmic radiation. But a new discovery raises a disturbing question. What if this magnetic shield is somehow linked to the oxygen we breathe? A connection so strong, so improbable, it challenges our understanding of how life evolved on this planet. Earth's magnetic field protects the atmosphere. The ozone, the oceans, and life itself all depend on this barrier against solar wind. On the other side, oxygen is the signature of complex life, two pillars of habitability. And yet, a recent study reveals that their levels have risen and fallen together over the past 540 million years. A coincidence or evidence of something deeper? Volcanic rocks preserve the imprint of Earth's magnetic field at the time they solidified. This field, called the magnetic dipole, can be traced using a science known as paleomagnetism. As for oxygen, it's harder to track, but traces remain: fossilized charcoal, air bubbles in salt crystals, and ancient sediment layers. Together, these clues allow scientists to reconstruct oxygen levels across hundreds of millions of years. And that's where things get strange. The two graphs match. For over 500 million years, when oxygen levels rise, Earth's magnetic field strengthens. When oxygen drops, the field weakens. Statistically, the correlation is over 70%. That's huge, and yet no one really understands why. But there's more. A sharp spike occurs between 330 and 250 million years ago. The magnetic field hits a peak, and so does oxygen. This moment just so happens to line up with the rise of a legendary supercontinent, Pangaea. So which came first? Does the magnetic field protect the atmosphere, allowing life to produce more oxygen? Or do geological processes, like plate tectonics, bring oxygen into the mantle, boosting convection and therefore the magnetic field? Some hypotheses go even further. Recycling of crust rich in oxygen through subduction zones could alter the chemistry of Earth's deep mantle, speeding up the internal geodynamo. In other words, life, indirectly, might be feeding Earth's core. But for now, it's all just speculation. Understanding this link could change how we search for life beyond Earth. If a strong magnetic field is essential to preserving oxygen, then only certain types of planets might host complex biospheres. And one day, by observing exoplanetary magnetic fields, through stellar wind interactions or radio emissions, we might predict which planets are capable of sustaining life. Until then, one thing is clear: Earth hasn't revealed all its secrets, and its magnetic heart might just beat in sync with life itself. If this video taught you something new, consider subscribing. There are more mysteries waiting to be explored. Stay curious, and I'll see you soon.